video we are going to discuss about the generation of Bpsk signals. On completion of this topic, the students will be able to understand the concepts of generation and coherent detection of Bpsk signals. So in Bpsk signal, it is nothing but it is a digital modulation scheme that conveys the data by changing or modulating two different phases of the carrier wave. So this can be of usually positioned with a uniform space that we call it as two-phase PSK or phase reversal keying. So in this type of technique, there is a sine wave carrier wave that takes place in the two types of the reversal. One is 0 degree, another one is 180 degree. This BPSK is basically a double sideband suppressed carrier modulation scheme that is used for sending the message for digital communication. So in the generation, this BPSK signal, we build it on the fact that it is in the special case of the DSPSC modulation. Here we are using the product modulator, which is consisting of the two components. One is non-return to zero encoder. Here this input binary data sequence is encoded and in polar form, so with the symbols of 1 and 0, which we are representing in the constant amplitude. In the product modulator, what it does mean, it multiplies the level encoded binary wave by the sinusoidal carrier of the amplitude to produce the BPSK signal. So finally, the timing pulses that which we are using for this level BPSK signal to generate the level is to encode the binary wave, and the sinusoidal carrier wave are usually generating the timing pulses based on the product modulator, but not necessarily this is extracted from the common master clock. It is usually based on the timing pulses that is used to generate the level encoded binary wave. And the signal of this B is represented as R1 is equal to root of 2 divided by TB integral of root 0 to TB and D of T root 2 EB divided by TB cos omega C T plus theta plus omega of T cos omega C T plus theta into dt. So for this 2 by TB we are operating as root EB. In the BPSK transmitter, when the data we are transmitting to as an input, it is first converted to the level encoder. Here this converts to the binary product modulator, then it gives to the balanced modulator. So this balanced modulator consists of the carrier detector, so that it both gets synchronized and it forms a balanced wave. So this carrier wave along with the balanced modulator is given to the bypass filter. This filter will filters the unwanted noises, distortions in it, and finally it is modulated as a PSK output. So the above figure shows the balanced range modulator. This modulator has two inputs. One is having the carrier is in phase with the reference oscillator and the binary digital data. So for the balanced modulator to operate it properly, this digital input voltage should be greater than peak carrier voltage, and while ensuring this digital input controls the both the on and off states of the diodes, that is from D1 to D4. If the binary data, that is if the binary input is logic 1, for example, if it is a positive voltage, means diodes D1 and D2 are forward biased, and while diodes D3 and D4 are reverse bias, it is off condition. So with these polarities we are considering the carrier voltage which is developed across the transfer in off phase or in on phase. This output signal, when it is in phase with the reference oscillator, it produces the logic 0, and if it is in off phase, it produces the logic 1, that is it can be reverse biased or it can be forward biased. So as a result of this, the carrier voltage which we are developing can be either 0 degree or it can be 180 degree. And the applications of BPSK, the BPSK modulation is very basic technique which we are using in various wireless standards such as CDMA, WiMAX, WLAN 11A, 11B, 11G, 11N, satellite, DVB, cable modem, etc. And it is considered to be very robust among all the modulation types due to the difference of 0 degree and 180 degree between two constellation points. Thank you.